So, sorry about that brief interruption. So we talked already about errors of omission, where we forget something, errors of commission, where we add something in or misremember the details of an event, usually include things that weren't part of our memory, including the demonstration we did a week ago, where you misremembered words that weren't presented in lists. Those are examples of errors of commission. I want to talk a little bit about interference effects in memory before we get into talking about suggestibility. The suggestibility is a little bit related to this idea of interference. And what happens with interference is this has to do with sort of the timing of which memory events can occur. So in retroactive interference, something that happens after an event goes backwards in time, and interferes with our memory for an event. So it's retroactive. So for example, let's say right after this you had sociology, and then later on you were asked to remember what happened today. Your sociology might interfere with your memory for what happened in this psychology class. That's retroactive interference. Proactive interference is the exact opposite. It's moving forward in time and interfering with your memory. So here we would be talking about previous experience interfering with your memory for a later experience. So if you had sociology before this class, that might interfere with your learning of psychology in this class. That would be an example of proactive interference. So the idea of retroactive and proactive have to do with which direction they're moving in time. Proactive memory interference is moving forward in time. Retroactive interference is moving backwards in time. It looks something like this. So you study psychology and then anthropology. Take your anthropology test, you might get proactive interference. Study psychology and then anthropology, you might get retroactive interference. I don't think it's really going to happen on your psychology or anthropology tests, but it's the basic idea here in terms of what direction in time things are moving. We used to spend a lot of time talking about this in terms of short-term memory, this idea of proactive and retroactive interference. What we're really going to be interested in is how this affects memory for life events. So we've already talked a little bit about things like how our knowledge affects our memory for events. So take away psychology and anthropology and substitute this with your knowledge about what happens in a convenience store robbery. You actually witness a robbery. Your memory for that robbery is going to be affected by the proactive interference of your knowledge. Now, today we're going to talk about suggestibility, where you witness an event, somebody asks you questions about that event, those questions interfere with your memory for the event, and later on become incorporated into that memory. So that retroactive interference is going to be what we call suggestibility. So the last type of memory error I want to talk about before we move on to talking about how retroactive and proactive interference results in suggestibility is this idea of our final memory failure, which is a partial memory failure. This is what we call the tip of the tongue phenomenon. So the last area where we sometimes get a memory failure is partial in nature. That is, we know there's a memory, but we can't drag it kicking and screaming into our consciousness, right? And this is always something trivial, almost always, right? Like, what is that actress's name that was in that movie that one time, right? That kind of thing. It's one of those things we call it the tip of the tongue phenomenon because you say it's right on the tip of my tongue. I know it. That memory's there, but I can't bring all of that information into conscious awareness. So this is where you've had a partial memory failure. You know the information's there, you just can't get to it, which is maddeningly frustrating. So the next area I want to talk about with memory failures has a lot more practical application in terms of how our memories can go awry. And what happens is we can actually misattribute the source of a memory later on. So a source misattribution is when we misremember the time, place, people, or circumstances involved with the memory. So somehow we confuse that source of a memory. Some examples of this kind of sources misattribution in the Roediger-McDermott DRM paradigm we did in class, where I read those lists of words related to one critical lure word and you misremembered that word. That's a source misattribution. In the examples we're going to talk about today, participants view an event, and then they're asked some questions about that event, and later on when they're asked to remember the event, they include information from the questions, that is, they misattribute the source of that memory and include them in the wrong place. So essentially what's happening is, instead of identifying a memory as being something you thought about doing, you actually remember it as something you actually did. So in the Memory Hackers video, you'll remember one of the things they had participants do is they got them to misremember committing a crime, specifically getting into a fight and having the police called. And if you remember, the way they got that to happen is they had participants imagine that it happened. So they picture in their minds being in a specific time with specific people that they already have in their memory, and then they have them imagine what might have happened to result in this fight. Later on, then they remember actually getting into the fight. They remember the police being called when none of that actually happened. Well, what's happened is, it's called imagination inflation. When you imagine something happening, you later remember that it actually happened, when it's actually only something you imagine having happened. So that's that kind of source misattribution. Your memory for imagining it happening gets confused with it actually happening. And younger kids are particularly susceptible to this. Kids are very susceptible to imagination inflation. So if they imagine something happening, they sometimes misremember it as having happened. So it's a really difficult issue to deal with. So the first study I want to talk about, Elizabeth Loftus was in that Memory Hackers video as well. She did this very clever study where they asked how fast a car was going when they got into an accident. So essentially, first thing that happened is they view a film of a car accident. And then they're asked how fast were the cars going when they either smashed, bumped, hit, collided into each other. So they all watch the same video, and some are asked different versions of this exact same question. And this is what we see. Those participants that were asked how fast were the cars going when they smashed into one another estimate the cars going 41 miles an hour. Those who are asked how fast the cars were going when they contacted one another estimated at around 31 miles an hour. 10 mile per hour difference simply by changing the way the question was asked. Nothing else is different about this aside from how this question was asked. So you dramatically alter someone's perception of an event based on how you ask the question. This is a really important lesson when we start talking about how do we handle eyewitnesses in police investigations. So by changing the phrasing of this question, you can alter people's memories for the event. Not only were their speed estimates changed, so were their memories. That is, participants who were asked how fast were the cars going when they hit each other, 14% remembered the presence of broken glass where there was none. This more than doubles to 32% when people were asked how fast were the cars going when they smashed into one another. And what's happening is, how fast were the cars going when they hit each other activates this kind of schema. It's kind of an accident, not bad. How fast were the cars going when they smashed into one another sounds much worse, activates the schema involving broken glass, and we more than double the false memory for the presence of glass when there was none. So what's happening here is this post-event suggestion, this question about how fast the cars were going, alters memory theory for the event. And so we actually get a change in the way we view an event based on that post-event suggestion. The other classic study by Elizabeth Loftus, participants view a video of a car traveling down a country lane. Participants know they're going to have to answer questions about it. Questions come up after watching the video. One of them is, how fast is the car going when it passed the barn? No barn in the video, but participants do exactly what you and I would do. Barn. I don't remember there being a barn. Is there a barn? I must have missed it. I must not have been paying attention, right? This is what you start thinking. So you're like, oh, I don't know, I'll just put something down. Well, then a week later, you come back. Asked to describe things like, please describe the barn in the video. Well, now, you remember, oh, yeah, that's right, there was a barn, because I wrote something down about a barn. So, fairly easily, you pluck one from memory, and you stick it in the video. Literally, this is how your memory works. I hate to break it to you. You put that memory back together, you just add in a barn that you've seen somewhere, and it fairly simply gets added into your memory. This is how our memories work. We put them back together. We have all the pieces to put that back together. And so now subjects describe in great glorious detail a barn that never existed. And what's happening here is, again, this idea of retroactive interference. Is after you're asked about the barn, you then go back into your memory, try to find one. Later on, all of that gets added back in together, and you remember things that didn't happen. This is particularly important because eyewitnesses are a pretty significant part of our criminal justice system. And there are numerous problems with eyewitness testimony. We don't have time to dive into all of their details today. But in addition to these post-event questioning problems, we actually have difficulty identifying ethnicities other than our own. What we think happens is, as your brain is developing, we start developing the ability to recognize faces. And we start being able to differentiate the facial features of those we see every day. And as a result, we tend to be very good at identifying faces of our own ethnicity and very bad at identifying faces of other ethnicities. As a result, we can actually very easily confuse faces from people who are of a different ethnicity than ourselves. And that's particularly problematic given our criminal justice system and the way it often works. Another thing that can be particularly problematic are the way police lineups are done. The way you see them done on television, they're hardly ever done that way anymore. Occasionally I'll see one get it right, but very rarely do you ever get this classic lineup of people. This would also be a terrible one because you're supposed to find people that are all fairly similar to the person that you're interested in. The way police lineups are supposed to be done is you show them a photo. All the participant or all the witness can do is say, yes, that's the person, or no, that's not the person. They only go through the stack of photographs once, and they can't go backwards. You would never put people together. You wouldn't lay out photographs, for example, and say, pick the suspect out of this lineup. Anyone know why you wouldn't do that? Yeah. Right, that's one of them. It certainly suggests that one might be part of the lineup. Instructions are key. You hit on a huge key point. One of the most important things police can do is say they may or may not be in the lineup. The worst thing you can do, which is kind of what you're getting at, is say, pick one, right? What else might be going on? That was excellent. Any other ideas? Well, if you're a witness to a crime and you're looking at a bunch of pictures, what do you think people often do? They pick the one that's closest, right? Rather than comparing this one face to your memory, you compare each face to each other and try to figure out which one's the closest. And that's not the task. The task is to match the exact face to the right person. So it's exactly right. People oftentimes are more likely to pick a person because they think they're in the lineup, and they pick the one that's closest. So the evaluation is wrong. When they're evaluating more than one picture at a time, they're trying to figure out which one's closest, whereas what you really want them to do is try to match it with their memory. Well, at the end of the day, eyewitness testimony is still a huge part of the criminal justice system. It's certainly one of the number one causes for overturned verdicts is faulty eyewitnesses. There's a great deal of scholarship on this. If it's something you're interested in, there's a ton of things out there on this issue. Certainly the Innocence Project has some really interesting information on it. Any questions about that? The last thing I'm going to put a note on this is there is a way to improve eyewitness memory. There's a thing called the cognitive interview, and it's designed specifically to get more accurate information. And in the state of New Jersey, it's actually a required procedure for handling eyewitnesses. The state of New Jersey State Supreme Court has probably one of the best reviews of the literature and eyewitness testimony in one of their decisions. And they actually talk about how specifically to handle witnesses, how juries should be instructed to evaluate witness testimony. So there is progress being made in this area. I want to talk a little bit about how our childhood memories can also be malleable. This is another sort of criminal justice issue. Elizabeth Loftus did this very famous, we call it her lost in a shopping mall experiment. Very much like the experiment they talked about in the Memory Hackers video where they got people to misremember getting into a fight when they were younger. Here, participants simply misremembered being lost in a shopping mall. So they interview the participant, they interview their parents and family, make sure this event never happened. They get 24 young adults like yourselves who never got lost in a shopping mall and separated from their parents. Bring the participants back in and say, well, we wanted to follow up with you about some things from your parents' interviews. They say when you were younger, you were out shopping and you got separated and you were lost for some time. Can you tell us what happened? Participants, much like in the Memory Hackers video, don't remember it right away, but then they're again asked to imagine. They're asked to do all sorts of techniques that are often used in therapeutic techniques to try to remember an event that may be lost or repressed. The idea behind this experiment and the other ones we've talked about in that Memory Hackers video are oftentimes to look at these kind of techniques used to recover memories that can then create memories. And so out of the 24 participants in this study, 7 of them misremembered an event that never actually happened. One of them, at least this is the lore, that one of the participants refused to believe that it didn't happen. Whereas when they went to debrief her, she said, no, I know it happened. I remember it specifically. So hopefully, it didn't result in some sort of huge family rift. She swears she was lost in a shopping mall when she actually wasn't. The take-home message from this is some of the techniques used that most modern therapists don't do this anymore, but there was a whole outbreaking of recovered memories in the 80s and 90s where people recovered memories of things that happened in their childhood that actually never really happened or likely never really happened. So you have to be very skeptical when somebody says that they've recovered a memory that they didn't have before. Pretty good chance it wasn't recovered, it was created. A couple final notes in this sort of applied area. Confidence is one of the main things a jury looks for. Were they confident in their memory? Were they really sure of it? The problem is that confidence and accuracy aren't particularly related to one another. People are as confident in false memories as they are in true memories. And the reason for that is they're not lying. They have a very clear memory. It's just wrong. That's all. And this is a huge problem when we rely so much on what people say to be true. And oftentimes it's simply people misremembering. People have actually been tried for perjury for lying under oath, when in actuality they probably just misremembered. So memory's a tricky thing. I think that's one of the things, and something we've seen this semester. One of the things I talk about is when you get into an argument about how something happened and what people remember, you're probably all wrong, right? None of you are right in terms of how it happened. Any questions about that? A lot more detail in that we could get into. We don't have a ton of time to talk about, but I wanted to make sure you had a basic understanding of this idea of suggestibility and reconstructive memory. So very briefly, I want to just introduce a couple issues when it comes to memory in the brain. The part of the brain that's primarily responsible for our memories is the hippocampus. The hippocampus is involved in consolidating our memories consolidating or permanently storing our memories. And what happens is, over time, memories go from being primarily dependent on the hippocampus to stored in other regions of the brain. This is one of the things that's happening while we're sleeping. Sleep is incredibly important for memory because of that. People who have damage to the hippocampus have what's called anterograde amnesia. That is, they're no longer able to form new memories. So patient HM that was talked about in the Memory Hackers video suffered from anterograde amnesia, could no longer form new memories. There's pretty good evidence for this idea of consolidation being primarily how memories are converted into long-term sort of permanent memories. One of the things we know is that every time you retrieve a memory, you reconsolidate it, which is why retrieval is such an important part of forming longer-term memories, but also why when we retrieve memories, you can consolidate new and different information into them. This is also how they were able to eliminate the fear from people who are afraid of spiders. In that Memory Hackers video, when it was reconsolidated, the fear was gone from that process. So the hippocampus is primarily responsible for that. The hippocampus is located right beneath the temporal lobes in what is called the medial temporal lobe complex. The rhinal cortex, hippocampus, and amygdala are all kind of wrapped up a little bit in memory, but certainly the hippocampus and the rhinal cortex are a huge part of our memory formation. In patient HM, they took out pretty much all of his rhinal cortex and hippocampus in both his left and right sides. You can actually go online and view sections of patient HM's brain because it was donated to a laboratory, and they have the whole thing sectioned out. And so it's a beautiful look at the interior of his, what was left of his brain, I should say. So they're very important. The rhinal cortex is very important for permanent memories. Our frontal lobes are also very important for memory. Encoding is involved in the frontal lobes. We see that higher activation of the frontal lobes during encoding is associated with improved memory. Now remember at the very beginning of the semester when I talked about how to improve your memory, one of the things we talked about is effort. You should be using some effort. You should be trying to elaborate on information. That's what's happening in these higher frontal lobe activation memories because there's more effort being involved, and as a result, these memories are stronger. We also know the frontal lobes are associated with retrieval. So when we're trying to retrieve a memory, they're also involved. In particular, identifying the source of a memory is a frontal lobe function. As a result, children are pretty bad at source monitoring because their frontal lobes aren't fully developed. As we get older, our frontal lobes start to deteriorate, and older adults also become very bad at source monitoring. Excuse me. The frontal lobes are particularly important for encoding and retrieval in memory. There's actually what's called the HERA model, which is hemispheric encoding retrieval asymmetry. A little more detail than you need for this particular course, but the frontal lobes are very important for that. It's the reason why people with frontal lobe injury oftentimes have memory difficulties, because they have difficulty both in encoding and retrieval. So we have the hippocampus, the rhinal cortex, and the medial temporal lobes, and the frontal lobes, all very important for formation and retrieval of our longer-term memories. Final note I want to make is on working memory, which we've talked a little bit about, and its executive functions. It's also a frontal lobe function, in particular what's called the dorsolateral prefrontal cortex, which I guess is all I have there under frontal lobes. Just simply note that those are also, that working memory and executive functioning is also done in the frontal lobes. And then, last thing I want to talk about is how stress affects memory and why that's an important part of understanding emotional memories. There's some belief that we have what are called flashbulb memories. That is, when there's a highly stressful event or highly emotional event, we're likely to encode that memory in all of its detail. These are usually studied when there's some sort of mass tragedy. So the ones that have been looked at in the United States are 9/11, the Space Shuttle Challenger accident in Great Britain. Princess Diana's death was studied as part of this as well. And so there's this belief people have that they have great memory for what happens during these kind of highly emotionally charged events. And there's kind of a lot of lore about it. Your grandparents probably say they remember where they were when JFK was shot. But it turns out these memories simply feel like they are better. They're not any more accurate. They just feel more accurate because they've got this affective component to them. So these kind of general stressful events, these kind of shocking events, don't seem to have any great memory associated with them. What do have differential memories with them are personally threatening, highly stressful memories. So this is where we can get into things like PTSD. The two things that are released by high stress situations are the hormones cortisol and the neurotransmitter norepinephrine. Both of these are part of our stress response. The problem is they have very different actions on our memory. Cortisol is terrible for our memory. In high stress situations, we have almost no working memory capacity. Working memory capacity gets shut down to almost zero. So we have no ability to work with or manipulate information. We're simply reacting to situations. Cortisol is also very bad for the hippocampus. So people who are under long-term stress have much worse memory performance than others. People who have depression have high levels of cortisol and also have difficulty with their memory. In opposition to that is norepinephrine, which actually boosts memory. So for some highly stressful events, you actually have very clear memories because they are over-consolidated because of the presence of norepinephrine. So sometimes this results in very clear memories for very stressful, personally stressful events. So we're talking about life-threatening events. And that can result in things like post-traumatic stress disorder. So it's important to understand that there is a relationship between stress and memory. Any questions about any of that? I feel like I ran through that very quickly. But need to move on to talking about learning. I'm going to warn you, some of this is somewhat tedious in terms of all of the details. There are a lot of details in this discussion of learning and reward that can be very confusing. So we're going to talk about the conditioned stimulus, the unconditioned stimulus, the conditioned response, and the unconditioned response. And you'll need to identify all of those on the exam for starters. So this is a classic part of psychology called learning and behaviorism. So when we talk about learning, we're not talking about what you're doing now, really. We're talking about a relatively permanent change in an organism's behavior due to their experience. So how do animals learn to find food, water, etc.? So very basic learning principles. Behaviorism is then the study of learning focusing entirely on the environment and behavioral responses. So we're back to basic principles of what is presented, what is the response. This is important because there's a lot of research still done using behaviorist principles. I can guarantee you, those of you who take the MCAT, what we're about to talk about will be on the MCAT. So you're going to want to make sure, spend some time with this information because it is really important. So one of the things we know about learning is it's highly adaptive behavior. That is, you can get permanent changes in behavior from relatively little experience. One of them is taste aversion. Anybody have a food they cannot eat because they threw it up once? Yeah, everyone has something, right? That might not be something you ate, might be something you drank. For example, I can drink tequila as long as I don't smell it. Smell it, it's all over. That'll give me the mouth sweats, as they say. That kind of taste aversion is adaptive. If something's made you sick, you probably shouldn't have it again. Probably shouldn't have tequila anymore, but I still do. So that's a basic part of this learning experience, is how these simple experiences result in permanent changes in our behavior. Because you can get what we call single trial learning, that single experience where something can alter your behavior for a very, very long time because of that sort of taste aversion. It's an adaptive behavior. We shouldn't eat things that make us sick. The first part of this we're going to talk about is classical conditioning. This is discovered by Ivan Pavlov. He's sort of the founding father of classical conditioning. This is sometimes also called Pavlovian conditioning. Pavlov was the original hipster, you can tell. Pavlov had an interesting job. I think this is in pre-revolutionary Russia, right? Pretty close to around the time of the Bolshevik Revolution. Anyway, he had this business where he sold gastric secretions from animals. For what purpose, I'm not sure. But he had this apparatus that would collect saliva and bile from dogs. And he discovered, by quite accident, that when the assistant who fed the dogs walked into the rooms, the dogs would start salivating. And he could see that because he was collecting their saliva. So he set about trying to study what was happening. Essentially, what he discovered was that the dogs were salivating in response to food. So whenever he fed them this meat powder. Sounds kind of disgusting, but it's probably just kibble, but not in kibble form. So they put the meat powder in the dog's mouth and represent that as a steak. It's going to salivate in response to that steak. So in this case, the meat is the unconditioned stimulus because it's going to elicit the salivating automatically, right? Because that's what it's supposed to do. Be like if everyone in here bit into a lemon all at once, you'd all salivate, right? Because that's what that causes. So the unconditioned response is the salivating in response to the presentation of the food. So the dog's given food, the dog starts to salivate. Pavlov would have loved my corgi. If you're actually eating, she'll sit right at your feet and then all of a sudden start drooling right on your feet. So you don't eat food barefooted because it's kind of gross. The first thing to understand about the unconditioned response is it is in response to the unconditioned stimulus, which is food in this case. In humans, this is a very simple experiment to do as well. I can puff air into your eye and ring a bell at the same time. If I puff air into your eye, you're going to blink. Everyone's done that at the eye doctor, right? That glaucoma test everyone hates. Anyone else hate that? Anyone? I'm like the worst at it because I can't keep my eyes open. As soon as I get up there, I'm like freaking out. So that unconditioned stimulus is that puff of air. In this case, if we were ringing a bell at the time, that would be, your unconditioned response would be your blinking. If we were ringing a bell, we could eventually train you, like Pavlov's dogs, That bell is a neutral stimulus, but we pair it with the unconditioned stimulus. So for the dogs, it's the steak. For people, we're puffing the air in your eye and making you blink. We ring the bell, give the dog steak. Eventually, all we have to do is ring the bell. The dog will salivate. Or if we ring the bell and puff air into your eye, eventually ring the bell and you'll blink just from ringing the bell. So here we have it again. The unconditioned stimulus, food. Unconditioned response, salivation. We present this stimulus, which is a tone. Dog doesn't do anything. We present the food, the tone, same time. Eventually the tone will elicit the salivating. So then that becomes the conditioned response and the conditioned stimulus. So the conditioned response is a learned response to a previously neutral stimulus. So it's still the dog drooling, but the dog's drooling in response to the bell or the tone instead of the meat itself. The conditioned stimulus is the bell. It starts off as a neutral stimulus, but becomes a conditioned stimulus. So we ring the bell, does nothing, it's a neutral stimulus. Eventually ring the bell, give the dog food, it starts salivating in response to the bell itself. Similarly, people, ring the bell, puff the air into your eye. Eventually ring the bell, you'll just blink. Fairly simple conditioned stimulus and conditioned response. So the response is the same response. It's still drooling, but it's what it's in response to. It's in response to the conditioned stimulus, the bell, it's a conditioned response. If it's in response to the meat, it's an unconditioned response. This is where things start to get very subtle in terms of their difference. So you want to spend some time thinking about what's the difference between the conditioned stimulus and the conditioned response. What's the difference between the conditioned stimulus and the neutral stimulus, and what's the difference between the conditioned stimulus and the unconditioned stimulus? Are you with me so far? So, classical conditioning is the basis of a lot of other types of learning. In fact, we'll see that there is some basis of classical conditioning with operant conditioning, which we'll talk about here in a minute. One of the things to understand about classical conditioning is this allows us to do a number of things when it comes to understanding animals. Animals can't tell us if they can tell the difference between one tone and another. They can't tell us if they can tell the difference between a blue light and a green light. But we can infer that they can tell the difference through this kind of testing. So, for example, we use a tuning fork, which is 1,000 hertz, and then another which is 2,000 hertz. If they still drool in response to the 2,000 hertz tone, that means they can't tell the difference, right? They don't tell the difference. We can do the same thing with a blue light and a green light. We present a blue light every time we give them food. If they drool when we put on a green light, they probably aren't telling the difference between the blue light and the green light. So this is one of the ways in which we can look at these kind of examples. So there are different stages of classical conditioning. Acquisition is the first stage. This is the initial stage of learning where we're pairing the conditioned stimulus, the neutral stimulus with the unconditioned stimulus, which makes that neutral stimulus a conditioned stimulus. So this is the acquisition stage. So we're going to pair the tone or bell with the meat. We'll do that a number of times. Then eventually the tone on its own will elicit a conditioned response. So that's the acquisition stage. It's the first stage of learning in which the animal starts to respond to the neutral stimulus and it becomes a conditioned stimulus. The animal has been conditioned to respond to the tone or the bell by drooling or blinking or whatever it's going to do. Extinction can occur if we continuously present the conditioned stimulus without presenting the unconditioned stimulus. So we just keep ringing the bell. Eventually the dog will stop drooling because it knows it's not going to get fed. Same thing with you and the eye blink conditioning. I keep ringing the bell. You'll blink until eventually you realize no puff of air is coming, and you won't respond anymore. So we can extinguish that response very quickly. What's interesting about this is you can get spontaneous recovery. That is, the conditioned response will reappear after a break. So you ring the bell a number of times or present the tone a number of times, the dog will stop drooling. Then you come back the next day, ring the bell, the dog will drool again, at least for a little bit. Not as long as it did in the first extinction study, but you'll get this kind of spontaneous recovery. Then if you do that enough times, eventually the dog won't recover at all. So it'll get rid of that conditioning. So you can decondition the animal as well. So acquisitions, when we start associating the conditioned stimulus with the unconditioned stimulus and getting the response. Extinction occurs if we present the conditioned stimulus on its own. Eventually the animal will stop responding. What spontaneous recovery is, we get this same pattern of responding after some sort of break. It spontaneously starts drooling again in response to the tone or the bell or whatever it is that we've used as our conditioned stimulus. A lot of lingo in this lecture, a lot of subtleties. I want to spend some time thinking exactly about what goes in which stage, how the animal is responding in each of these scenarios, and trying to get a handle on all of these terms. So this is kind of what this looks like. We pair the conditioned stimulus and the unconditioned stimulus together. We get some nice response. And we present the conditioned stimulus by itself, and we get less responding. We come back 24 hours later. We get a little recovery. And then another 24-hour break, a little less recovery. Then eventually we get nothing at all. This is a very basic introduction to this kind of classical conditioning. So one of the things we can look at is, and one of the ways we can start to infer animal learning processes is through testing stimulus generalization and distinction. So we'll stick with the tuning fork because it's a good example. We wouldn't use a tuning fork now. We would just present a tone via computer. But you can actually get what's called the stimulus generalization gradient, where the conditioned response will be elicited by similar but different stimuli, but the response will be less the further away from the stimulus you get. So for example, we have this tone that we present as the conditioned stimulus. Let's say it's 1,000 hertz. The further we get away from 1,000 hertz above or below, the lower our response is. So the closer we are to the initial learning, the stronger the response will be. The further away we get, the weaker the response will be. So that's what we call generalization. So we would call that a generalization gradient. Discrimination is a learned tendency to differentiate between two similar stimuli. So if we're interested in whether or not the dog can tell the difference between green and blue, we'll feed it meat powder every time we present the blue light, but never when we present the green light. So if it can tell the difference between blue and green, it should only salivate in response to the blue because it should have learned to discriminate the blue from the green, because we never present meat with the green light. Similarly, you can present two very similar tones and get conditioned response to one but not the other, because you know one is associated with meat, one is not. It would be the same thing. We presented two similar tones and did your eye blank with the puff of air. You would eventually learn which tone specifically was associated with the air, and you would only blink to that tone. And then we call that discrimination. Questions about those kind of procedures? I once had to teach an entire semester about this. So we got it done in 10 minutes, right? 15 minutes. It was actually this in Operant Conditioning. It was a long semester. So classical conditioning is basically how we learn to adapt to our environment. This allows us to predict what's going to be pleasurable, what might be painful. It's going to help us to learn what stimuli are associated with food. We're going to talk about the neural underpinnings of that when we talk about the reward pathway on Wednesday. But it really allows us to learn about our environment. So it can be things like a fight or flight response. Seeing a snake can trigger endorphins, which boost our escape abilities, which is obviously better than waiting for a snake to bite us. We also learn foraging behavior, what to look for, what's associated with good outcomes and bad outcomes. We learn which stimuli are associated with which outcomes. And that's essentially what's happening in classical conditioning. We're learning that this tone is associated with food, this tone is associated with something else. We do start to get associated with one another, and that's how we start to learn how to adapt to our environment by these automatic responses. In fact, they happen in people all the time. In studies of drug-abusing populations, your body starts to react as soon as you start to see cues associated with drug use. So, for example, in heroin users, if you show them the stuff they usually use to shoot up, their body starts responding immediately to that stimulus. In fact, your body will release enzymes that break down those drugs more quickly in response to that. It is a conditioned response. So, some applications of classical conditioning. The sort of classic, most nefarious example of an application of classical conditioning is a conditioned fear response. John B. Watson was very interested in development of fears, and he thought that he could develop phobias in an infant through a conditioned fear response. This is little Albert and his mother and John Watson. I think right there I'd be suspicious of John Watson and his ability to deal with infants. Just saying. Essentially what they did was Watson thought that all people were born tabula rasa. That is, we're all blank slates and everything is then written in our experience. So he thought that if somebody was afraid of something, they had to have been conditioned to be afraid of that there were no innate fears, that all fear was conditioned. We learned to be afraid of things based on experiences. We observed fear in others, which made us afraid, that sort of thing. So, what they did with little Albert is they placed a little stuffed white rat in little Albert's crib. As he was presented with the rat, as the tale goes, John Watson stood next to the crib with a piece of metal and a hammer, and as soon as they presented the rat to the infant, he smacked the piece of steel, making this huge loud noise. Infants don't like that, causing the infant to be startled and afraid of the white rat. Well, it turns out little Albert was afraid of everything furry, anything white. We don't really know whatever happened to little Albert. All we know is that his mother took him out of the study before he could be deconditioned, which Watson swore he could do. But essentially was able to demonstrate that you could condition a fear response immediately. So think about what the unconditioned stimulus and the unconditioned response are versus the conditioned stimulus and the conditioned response. In this case, it would be, anyone know what the conditioned response is? Yeah, so it'd be probably him crying and being afraid. We can assume that fear is in there somewhere, but we're behaviorists, so we assume he's crying, right? But what's it in respond to if it's the conditioned response? It's the white rat, right? So a little stuffed white rat. The unconditioned response is the crying in response to the loud noise. The unconditioned stimulus is the loud noise. The conditioned stimulus is the white rat. Which now, and also it turned out like Santa Claus and white beard, all sorts of other crazy stuff. Poor little Albert. He probably ended up working at the post office or something. So that's the thing you have to start thinking about, is what are the conditioned stimuli and the conditioned responses. So as I said, one of the things we know is drug use and classical conditioning often co-occur together. People oftentimes can quit smoking until they go out and start drinking, and then that cues them to smoke again. In fact, there's a lot of people who are what we call social smokers. We also know that cues associated with drug use can cause certain biological reactions. People who use cocaine would oftentimes start producing enzymes to break down cocaine in the liver. One of the things that happens is people who stop using for a while and then start using again, their body has stopped producing enzymes in the same quantity, and as a result they can overdose more easily because they're not equipped to process out drugs as quickly. Questions about classical conditioning before we start on operant conditioning? Yeah. Yes. And then the conditioned response is the same response, but in response to the white rat, because they paired the white rat with the sound. And so it goes from being a neutral stimulus to a conditioned stimulus. Yes? Yeah, so essentially it's extinguished their response because they simply haven't had that stimulus associated for a while, and so they don't give that same response that they would. There's a number of other things that are associated with that, but that's one of them that can happen. Any other questions? All right, let's talk about operant conditioning. Operant conditioning is a learning process which is based on consequences. What follows an action determines the likelihood that it will be repeated. So here we're talking about reward and punishment. If you haven't seen Mommy Dearest, I would recommend it. She's about to beat her daughter because she dared use a wire hanger. That's why I have this up here for operant conditioning. So we're talking about anything that's followed by something pleasing is more likely to be repeated. Things that are followed by punishment are less likely to be repeated. So we're talking about a learning process based on consequences. Operant conditioning is basically how we train animals, how you train your dog to sit, stay, use the bathroom outside. All of those things are based on operant conditioning. Any of you have ever been to SeaWorld? Seen whales jumping through hoops and dolphins and sea lions and whatnot. All of that's based on basic operant conditioning. So most of you, of course, are familiar with the idea of positive reinforcement, right? You positively reinforce an action, means you're giving someone a reward for having completed an action. That's an operant conditioning principle, is positive reinforcement. We also have to, of course, think about positive punishment, which is the infliction of some sort of negative consequence. And we'll also talk about negative reinforcement and negative punishment as well. So I'm not sure why Thorndike's law of effect is in two different colors, but this is Thorndike's law of effect. Behaviors followed by favorable consequences become more likely, while those favored by unfavorable consequences become less likely. What I'm going to do is show you a clip that demonstrates Thorndike's law of effect fairly effectively. Maybe. Oh. I'll have to back this up. Try to There we go.
Finished? Thank you. How thoughtful. Would you like a chocolate? Yeah, sure. Thanks. Oh, sorry, Sheldon. The phone was off. Gave to you? I didn't notice. Get a chocolate. Thank you. You're here a lot now. Oh, am I talking too much? I'm sorry. Thank you. Chocolate? Yes, please. Oh. Hey, Tim. Yeah. You know what? Hold on. Let me see if it's in the hall. You'll never guess who got pulled into this. Okay. I know what you're doing. Really? Yes. You're using chocolates as positive reinforcement for what you consider correct behavior. Very good. Kelly, you can't train my girlfriend like a lab rat. Actually, it turns out I can. Well, you shouldn't. There's just no pleasing you, is there, Lemon? You weren't happy with my previous approach to dealing with her, so I decided to employ operant conditioning techniques, building on the works of Thorndike and B.F. Skinner. If I do some next week, I believe I can have her jumping out of a pool, balancing a beach ball on her nose. No, it has to stop now. I'm not suggesting we really make her jump out of a pool. The Zynga was implied. It's tweaking her personality. It's sanding off the rough edges, if you will. No, you're not sanding any. Are you saying that I am forbidden from applying a harmless, scientifically valid protocol that will make our lives better? Yes, you're forbidden. Bad, Leonard. You know, using positive reinforcement techniques, I could train that behavior out of her in a week. No. Would you let me use negative reinforcement I can't done before we go to bed? You're not squirting her in the face with water. No, of course not. I'm talking very mild electric shocks. No tissue damage whatsoever. Forget it. Come on. You can't tell me that you're not intrigued about the possibility of building a better girlfriend. Well, in hindsight, both good and bad, I would make her who she is. You mean like that high-pitched, irritating laugh? Yes. You mean you prefer a throaty chuckle? You're not changing how Penny laughs. No, that would be incongruous. I'm going to lower the whole voice to more pleasing register.
I'm sorry, guys. That girl is freaky.
Come again?
Freaky.
Freaky?
Yeah, freaky.
Have a chocolate.
Thank you.
Well, Pavlov had made some form reveals when you turned in. I trust in case you were planning on engaging in amorous activities, you'll keep the decibel level to a minimum.
Of course.
Thank you.
All right, so that's an introduction to operant conditioning. Where are we? As you saw, they talked about Thorndike's law of effects, and B.F. Skinner are certainly the founders of this field. A couple things about Thorndike's law of effects is one of the things that Thorndike discovered is there is a sort of temporal limit. That is, things have to co-occur in sort of closer in time in order for them to be effective reinforcers or punishers. So unfavorable consequences are called punishment. Favorable consequences are called reinforcers. But they do have to occur relatively close in time. in order for the two to be associated with one another. It's one of the reasons why people spend more money with credit cards than they do with cash, is because the consequences of credit cards are much more delayed until you actually pay the bill, whereas cash, the money goes right out when you hand it over. So people tend to spend more with credit cards than cash because of that. We'll actually talk about how spending patterns are associated with conditioning and reward on Wednesday. B.F. Skinner, also mentioned in the clip, sort of the major founder of operant conditioning. Certainly a pioneer in his field. Skinner did a number of pretty remarkable things in terms of learning how to adapt animals. One of Skinner's sort of most outrageous bits of research is he got a grant from the Defense Department during World War II to develop a pigeon-guided smart bomb, in which he trained pigeons to keep a bomb site centered in on a ship. So the pigeon would actually peck the screen to keep the ship within the bomb site. The problem is each pigeon was a single use because they were inside the bomb. So it didn't turn out to be a particularly effective strategy, and it was never deployed because the war ended. But you can actually look up that. Rather interesting. He also developed what's called the Skinner box. This would be a pigeon version of the Skinner box. This is similar to what we used when I was an undergraduate. I actually had a learning psychology lab where we got to train a pigeon. So the pigeon is trained to peck one of these two keys. The one we had 3 keys that they could peck, and then they're rewarded with food down here. Ours were tied in with Macintosh computers. This one's probably just tied in with manual response units. This is actually the one we use. So the computer would actually signal which one of these keys you could use a different colored light, and then you could reward the pigeon that way. We'll talk here in a minute about shaping. One of the things you have to do is teach the pigeon to actually peck the key, because you don't just set it in the box and it starts pecking at everything. So basically what you have to do is turn the light on, and when the pigeon goes to move forward, you give it a little food. Then when it gets a little closer to the key, you give it food again. It's called this method of successive approximation. So you sort of get it closer and closer to the behavior you want. So eventually you'll get it to peck the key, and then it learns to peck the key when it lights up. We taught ours to do some dance moves. We taught him to turn all the way around once and peck the key, and then turn all the way around again and peck the key again. So that was pretty exciting. This is sort of the old school version of this. You had this sort of pen deflection system, so every time the bird responded, the pen moved up the graph, and then it would start over again. So when you see some of the graphs in this area, that's why they look that way. Ours were, of course, associated with computers. Rats are also trained in Skinner boxes. Instead of pecking keys, though, they press a lever. Pretty straightforward. You'll also see you can deliver an electric shock to the floor of this apparatus. It's one of the things we saw, again, in the Memory Hackers video, where they taught the rat to be afraid of the tone. So the way we teach animals in this kind of operant conditioning environment is through this process called shaping. So the process of operant conditioning that involves reinforcing behaviors that are increasingly similar to what you want the animal to do. So you don't start them off on the full behavior. You get these, you get them to get closer and closer, and that's why it's called the method of successive approximations. Because each time you want the animal to get a little bit closer until they actually complete the entire process. And then you only reward them when they get closer or they actually engage in the behavior itself, so they learn exactly what it is that you're after that will get them their reward. So we named our pigeon Forrest because he was like Forrest Gump. He learned really quickly. We shaped him, had him pecking keys in no time, and then when it came time to do the experiment, Forrest really let us down. We were always the last ones done, and I hated that pigeon. He was so dumb. He would just stand there. The light would be on, and he'd be like, Come on. Hated that bird. Anyway, that's Forrest. In these kind of experiments, you keep animals at what's called an 80% weight. So what happens, the very first beginning of the semester, you weigh the pigeon and just feed them as much food as they'll eat. And then once their weight has stabilized, you cut back their feed so that they are about 80% of that weight. So that they're generally motivated and hungry when they get into the operant conditioning chamber. If you're wondering how you weigh a pigeon, you actually stick them in a beer pitcher head first, and then they're perfectly happy upside down, and you weigh them. It's also how you carry them to the lab. So it's kind of strange. You'd see our TA walking around with like 6 pitchers full of pigeons. Being a psychology graduate student, you have a lot of weird things. We also had a rat lab, but they used what's called the Morris water maze. So you'd see people walking down the hall toweling off rats. Life was strange back then. So let's start on the principles of reinforcement. We'll probably pick back up on this on Wednesday to kind of reinforce this a little bit, so to speak. A reinforcer is any event that strengthens the behavior it follows. So this is a reward. This is giving Penny her chocolate, giving Forrest Pigeon his pigeon chow. Literally, that's what it's called. A primary reinforcer is anything that is innately reinforcing. So food, sex, removal of pain is reinforcing. In some studies with rats, the rat can directly stimulate the reward center in their brain, and so that's very reinforcing. These primary reinforcers are things that tend to be associated with survival: food, sex, not being in pain, right? Secondary reinforcers are a learned reinforcer that is associated with the primary reinforcer. And this is where classical conditioning and operant conditioning come together. Because the secondary reinforcer is classically conditioned to be associated with the primary reinforcer. So it's eliciting the same response. So those of you who are familiar with dog obedience training, they use clickers. And that clicker is associated with food, and then that clicker becomes a secondary reinforcer. In people, money is a secondary reinforcer because it allows us to get things like food and sex. I mean, not directly. Well, usually not directly. Certainly food. Money sort of secondarily gets us at sex, right? Gets us out of the house, gets us places we can buy good clothes and whatnot. So we talk about this idea of primary and secondary reinforcers. We will pick up on positive reinforcers, negative reinforcers, positive punishment, and negative punishment on Wednesday. Any questions? All right. See you guys on Wednesday. We'll pick up right here.